Sapphire Rapids is in the house, literally and figuratively, with the W790-ACE. Now, if you didn't catch my other videos on this, I've already done a build with this. You should really check out my other videos, W790, Why You Gotta Be Weird. And also, the workstation system that we got directly from Falcon Northwest. These parts are so expensive, I really don't recommend these kinds of builds for the uninitiated. But unless you have somebody like Falcon Northwest build your system for you, you're leaving a lot of performance on the table with these new Sapphire Rapids CPUs. Intel ships them very conservatively, but they're also very stable for a long-term overclock. I've been running Xeons, X-Series Xeons, since 2019 with pretty stable overclocks. The W3175X could overclock very well and has basically been running 24/7 at 4.6 to 4.8 gigahertz. And so far, knock on wood, these higher end Xeons are basically proving to be the same. Kind of like how on Intel desktop CPUs you can have the 200 watt unlock and just let the CPU run at that all the time. You can basically do the same thing with Sapphire Rapids as long as you can keep it cool. But that doesn't even mean that you need exotic cooling. Our Falcon Northwest system uses a Silverstone semi-custom AIO to cool the CPU, and boy howdy can it do it, up to 800 watts. It's very, very impressive. That might not be for everybody though, and maybe some people do want to DIY. So this is the other W790 platform that's 4 memory channels. Now because it's 4 memory channels and it's not really meant for the highest end CPUs, things are a little different. We're going to do a build, and we're going to do a dual power supply build. And yes, like the Falcon Northwest system, this will absolutely run circles around the same processor in a workstation configuration, say from HP. Yeah, that's right, the Falcon Northwest system will also run circles around systems from HP, Dell, and others based on the same processor. It's a weird world we find ourselves in. But let's get this thing put together and we'll take a look. Now the perfect case for this is the Lee Dynamic, because it's one of the very few systems that will support dual power supplies. Now this is just the regular Dynamic, and if I had my choice, really I'd probably have gone for the Dynamic XL, but I'm not ready to tear down my W3175X system with the dual 360 radiators and the custom AIO. One, because I don't think there's a custom block for this yet, and two, because, well, Tower Cooler and Noctua is really going to do this. Now check out Noctua's full line of tower coolers for the LGA 4677 socket. There's 2 coolers that would be appropriate for not 500 watt CPUs, but that will work great in a tower configuration or even a 4U rack mount chassis. Did you know the least expensive CPU for this platform is only about $300? And a 16P core processor for this platform is also less than $1,000. And the W790-ACE motherboard could make a lot of sense if you're going to use one of those processors. I was with ASRock and Computex in 2023, and Splave, the world famous overclocker, and Nick, the other world famous overclocker, they work for ASRock, and they do really awesome stuff for performance tuning. They're on the performance team at ASRock. They're literally the people that figure out how to juice things to give you a little bit more performance. And ASRock has their own workstation board that I'll be covering soon, but we got the 16-core Sapphire Rapids CPU to 7.2, 7.3 gigahertz, and it was over 6 gigahertz stable, Cinebench stable, on liquid nitrogen. This is good quality silicon, and yeah, when you do that at 16 cores, it's going to use about 45 watts per core, which is not a lot different than the desktop parts, but still, that tells you how much headroom there is with Sapphire Rapids, and maybe how much performance you'll get out of the core, assuming that a die shrink or a process shrink will bring you a little bit more power efficiency for the silicon, because the performance would probably stay about the same. The clock speeds generally don't improve anymore with the shrink, but I'm getting ahead of myself. Really, I just want to put these parts together and see how this does. And being able to run dual power supplies on the W790-ACE is one of the headline features of this motherboard, and I have not been able to do that on neither the Sage, nor the ACE, nor any other board, so gosh darn it, we've got the Lee Dynamic 011, and that's what we're going to do. Now, even though technically the ACE motherboard is just a little too large for this case, it still does fit and it doesn't block your fans. It's just that the motherboard is overhanging the curved ledge of the Lee & Dynamic case. But you still got a fair bit of room at the bottom and sides of the case, so we're not doing too bad. It's going to be a little bit of a problem for our 140mm cooler in the Lee & Dynamic. Should have gone for that Dynamic XL. You see my problem here? It's one of a clearance. What's the clearance, Clarence? Roger, Roger. Huh? Not to worry. Not to worry, I've got the 120mm version of this tower cooler, which also does shockingly well. We're just going to run it without the side for now just to see what the top end performance of this is, and then we're probably going to dial things back a little bit and swap in a 120mm cooler. Now, since we're going to be dual wielding power supplies, I just so happen to have some Be Quiet Dark Power 13 power supplies. Now this one, it's pretty hefty, but it's 850 watt, and it's got the PCIe 5.0 connector. So get the wee little connector, which is great for gaming GPUs. Not really great for inferencing GPUs, like if you're gonna run RTX 6000s, it doesn't really help you much. You can still use the other kind of cable, it's fine. But it is a little bit of a magic trick because two 850 watt power supplies for this chassis configuration will give us 1600, 1700 watts. Two power cords, sure, but that'll probably work really well. The only thing you gotta watch out for is if one of your power cords comes unplugged, your machine might not post. So you gotta be careful that all of your power cords are plugged in the same place so that doesn't happen. Because dual power supplies is sort of a weird thing. W790, why you gotta be weird? But yeah, we'll be fine. Dark Power 13. I really do like Be Quiet power supplies. Why? Because they be quiet. Now when you're doing single power supplies or dual power supplies, you really have to pay attention to the colors and connectors on the motherboard. It is possible to plug in the two power supplies incorrectly and dramatically increase your chances of damaging something. So if you're running a single power supply, the diagram shows that you need to use the gray, 24-pin connector plus two of the gray connectors, one ATX 12 volt for the CPU, one of the two connectors up near the CPU, plus the other one at the front edge here, which is actually PCIe power, and then one of the black 12 volt connectors here. But for dual power supplies, it's mostly black for your secondary connections and gray for your primary connections, which means that if you have a single power supply and then you decide to later upgrade to a dual power supply, you will have to unplug this secondary cable that's here and move it to the connector behind the CPU, because gray is primary, remember? So your primary power supply will be the gray connector in the front, plus the gray connectors here, and then the gray connector for PCIe 12 volt at the front edge of the motherboard, and then your second power supply is the two black connectors for CPU power here, plus the black 24-pin connector. That is the safest, because, well, to make a long story short, 12 volts is not always 12 volts. This power supply might be 12 volts, 12.00 volts, and the other one might be 12.03 volts, and unless the resistance between the power supplies is balanced correctly, a lot of current can flow from the difference between 12 volts on one side and 12 volts on the other. Okay, I'm leaving a lot out and really oversimplifying, but the motherboard designers really have to be careful when you're doing this dual power supply thing, because it's like the days of yore when you had a multi-rail power supply, wherein ultimately we decided, it's not a great idea. In this case, multiple rails come from different power supplies. So again, it's a lot of exposition to just say, be careful, follow the diagram. Where does one go to install the RAID key, to install Virtual RAID on Chip? Now, Virtual RAID on Chip is a kind of 25% hardware assist proposition on the Intel platform. Generally, it works better than anything that AMD has. I don't really recommend RAID in a desktop configuration for a lot of reasons, but it can help performance in some scenarios. It generally doesn't help with latency-driven scenarios, which is what dominates a lot of usage. So I don't know that I would recommend a RAID volume for a boot volume, but for a data volume, sometimes it can make sense. And just for the purposes of this video, it's like, hey, let's experiment and see what's going on. And I'm going to try to make it a boot volume, just to see how it goes. So we got the Asus Hyper M.2 X16 card, which I've acquired separately, and it is outfitted with 4 Samsung 980 Pros. We're going to enable VROC for this slot, and see if that's all we got to do. Now the awesome thing about ASUS boards is they generally almost always label the PCB correctly. So slot 5 is at the bottom. Some boards slot 1's at the bottom and slot 5's at the top or whatever. In this case, slot 5's at the bottom. When we enabled VROC for the bottom slot, I was hoping that it would go ahead and enable that to run in an X4, 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 X4 configuration. That was not to be. The option in this BIOS is under another menu. Your princess is in another castle. Yeah, so you have to change that. Now, one really annoying thing astute observers will notice is that it only supports X16 and 4X4. There's no X8, X8 option. That's going to annoy some of you because some of you use custom breakout cables like I do to cram even more devices in here than you're supposed to. So somebody inside of ASUS was like, oh, no one needs the X8, X8 option. We should simplify it. Stop it. Stop. Don't do that. Simplifying makes some of these weird edge cases, the people that are spending thousands of dollars on these motherboards, not buy them. Don't do it. Well, I can't really say I expected any different. RAID unsupported, it's just going to pass through. So we'll try to set up Windows and see how that goes. So you must be thinking, oh, it'll work fine with Intel SSDs, right? Well, what if we try Solidigm SSDs? Because does Intel really have consumer or enthusiast SSDs anymore? It looked like Solidigm. Remember the Solidigm booth from Computex? The close-ups? Gosh, those look an awful lot like the Intel P4500, except about 47 generations newer. Yeah, those are Solidigm though, not Intel. And guess what? Unsupported RAID! Intel, come on. What are you doing? Seriously? What are you doing? Alright, so we got VROC, the software, installed on Windows. You know, I installed Windows to just a single SSD. There's 4 in here. And I was hoping I could convert it to a RAID 10 volume. I mean, VROC detects it. It wouldn't let me do that. It was just grayed out the boot drive. But it did let me select the 3 other drives, which I was able to configure in RAID 5. And that gave me about 4 terabytes of usable space. And also configured the closed RAID write hole as distributed, so maybe that'll close the RAID write hole. You can also use another device apparently for journaling, so maybe a small Optane. That'd be pretty cool. Alarmingly, once I started initializing the array, it said days in trial remaining 0. I don't know what that means. Does that mean that it's not going to work? Does that mean that it requires a license that I don't have? It's it's a great way to give customers exactly 0 confidence in your product to do this. Don't do this. Might as well just not have it. Anyway, it seems to be working fine. It's still a mess, and honestly, your money would go better toward a hardware NVMe RAID controller, because this is not a fabulous experience. Let's do XTU, because I know that XTU is actually not going to be a terrible experience. XTU is actually pretty awesome. Intel XTU, if you're not familiar with it, is Intel's software overclocking utility. Even though this is an ASUS board and it's got the Extreme Tweaker and the DigiPlus and the Tweaker's Paradise and blah blah blah, XTU's got all that beat all to pieces. I mean, I can enable XMP Profile 1 in the BIOS. That really does set a lot of options. I can set the thermal limits on the processor to 90 degrees C. I can tell it that I want an all-core turbo. I can unlock the power limits in BIOS, but XTU basically lets me do all of those things. Well, it's subtly different when we're talking about setting the XMP profile, but that aside, basically all the same stuff. So Intel XTU, to unlock the processor, yeah, we can let it run at non-stock defaults, still perfectly stable, and boom, an extra 20% performance. Let's take a look at Geekbench. Here's our Geekbench score with a totally out-of-the-box configuration. And then here's our Geekbench score with a very conservative 100% stable overclock. Again, still using our Noctua Tower cooler. We're not using anything exotic for cooling whatsoever. So we're doing a little experiment here with Intel XTU and our Noctua cooler and power settings. And there are power settings in Intel XTU for both wattage and amperage. And it seems like it would be easy to say, oh, our Noctua cooler is rated for about 550 watts of cooling. But that's not the whole story. I should just dial in 550 watts and have it work. But as you can see from just running Cinebench, just a real quick, we quickly get up to that 90 degrees C thermal throttling thing. We've actually got a little bit of thermal headroom at 90 degrees C. We could go a little hotter, but I'm not going to push things. The thing that you want to do is dial in your amperage, but because the CPU uses slightly more than 1 volt, you don't want to set the amps to the number of watts, because watts is equal to volts times amps. So we actually want to set it a little less. At about 322 amps, you shouldn't encounter thermal throttling in pretty much any scenario, even Cinebench R23, even in this configuration, assuming that you've got lots of good airflow from the side here, pulling in a lot of fresh air to flow over your Noctua cooler. Now, one thing that our Lian Li case is not fabulous about is that it doesn't have a super direct path for the rear I/O. The vent at the rear here is not large enough, in my opinion. So having a fan located at the top pointed out to pull air out of the top this way so that you get kind of a chimney effect, I think really helps cooling when the thing is fully assembled. Of course, when I'm testing this, it's basically open air, so it's sort of a best case scenario for cooling with this cooler. You can use Hardware Info 64 and Intel XTU to dial in a setup once you've got your system fully assembled. And as you can see from our Cinebench results, we can get 49,000 at the very top end for a 24-core machine, all the way down to about 41,000 for our multi-score. So that's that's like a 20% variance here from 300 to 600 watts. Would you get better performance with an AIO? Yeah, sure. This also doesn't take into account AVX. When I'm running multipliers like 48, 49, 50, you will need a negative offset for your AVX2 and your AVX512. It just uses too much power and generates too much heat. For most real-world applications, you won't really notice that. Again, Intel XTU offers you utilities where you can set application-specific profiles. So if you're going to play a game, you can set a profile in XTU for that game so that you'll get those really high single-core bursts, which in this case on the Xeon, we're not talking 6 gigahertz. 6 gigahertz is going to require liquid nitrogen. Literally done it. I made the 16-core Sapphire Rapids Xeon. Well, okay, it wasn't me, it was Splave and Nick, but we made the Sapphire Rapids, the Royal we, go as fast as this 24-core system is going in multi-core, but at a cost of about 900 watts. Whereas, according to the kilowatt, on this configuration, we're peaking at about 600 watts at the very highest end configuration, but our configuration that's at about 322 amps, keeping us well under that 90°C threshold for extended Cinebench runs, is more on the order of 450 watts at the wall, which means that our cooler is dealing with substantially less than that. Yay! For the memory for this workstation, G-Skill Zeta R5. Yep, it says right on the back, overclocked DDR5 RDIMM for use with Xeon W2400X series processor 4-channel motherboard. You can use 2 of these for the 8-channel motherboard. This is DDR5 6400. I cannot get over how easy it is to get DDR5 over 6000 working on this platform as compared with desktop. Even Intel LGA 1700 has got some rough edges, whereas W790 has basically been trouble-free. It really is a server platform, but that has XMP overclocked memory profiles. Listen, story time. 2017, 2018, 2019 Computex, I was wandering around asking every memory vendor, hey, I really think we should do error-correctable, error-correcting registered RDIMMs, ECC UDIMMs. I went so far as to bend and solder my own DDR4 3200 ECC UDIMMs by hand picking chips and replacing decoupling capacitors. And it took a couple $1,000s to produce 2 DDR4 3200 DIMMs that I had in a video forever ago, but I also explored commercializing it. Maybe that was something we could sell on the level 1 store. I harassed G-Skill to the point that they really didn't even want to talk to me anymore about it. And here we are, just a short time later in 2023, and it's a commercialized product. Sorry. Anyway, 4 DIMMs, 4-channel platform. This is what we're gonna do. Now remember, the 3000 series Xeons, those are 8 channels, different motherboard. You want the Sage instead of the ACE. Even though on the motherboard compatibility list, this does list the 8-channel Xeons, and they will work in here in a 4-channel mode, you get more PCIe lanes and more memory channels with the higher tier Xeons, whereas, on this platform, it's a little more modest. This motherboard does have 8 slots, which means you can run 2 DIMMs per channel. However, 2 DIMMs per channel also suffers a performance penalty, so don't do it. Running up to 1 terabyte on the W790-ACE is pretty easy, although it does support up to 2 terabytes of memory, Whereas the W790 Sage, like we saw in our Falcon Northwest system, 4 terabytes, no problem. Another important piece of information here is that these registered DIMMs really don't like temperatures above 60°C. They can introduce instability problems, so you're going to need appropriate airflow over your motherboard to keep your DIMMs cooler. And the stickers on this memory are just stickers. They're not even foil, so they don't really act as a heatsink. It would have been nice to see a nice thin heatsink or something on that. I'm sure that G.Skill is going to address that in the future, because they're going to discover what I discovered, which is unless there's a lot of airflow, the memories on the ICs are very sensitive. And depending on what workloads you're running, the memory load and the temperature as a result of the load can vary hugely. For normal things like gaming or even running Cinebench, it doesn't generate a lot of memory traffic. If you run something like a Y-Cruncher, you're going to need active cooling on the memory, or active large amounts of airflow around the memory. Fortunately, with the tower cooler design, not a problem. But if you were using an AIO or a custom loop, then you're going to need to make sure that you got plenty of airflow around the RAM. I was pulling my hair out in the beginning when I was getting acclimated to this platform because I was having weird intermittent instability issues, and it turned out it was memory related because the memories were running over 60°C. So something to keep in mind. Also, don't touch the edge of the memory. That was also something that I've sort of encountered on the desktop platforms as well as server. Don't touch the edges of the memory. Make sure that they're super squeaky clean, because just having a tiny little bit of debris on the connector or just a little bit of residual finger oil on those edges can throw out the memory timing and introduce very slight instability. Sounds insane, I know, but trust me. Now with our full kit installed and running a DDR5 6400, we're looking pretty good. 150 gigabytes per second, give or take, according to our ATA 64 memory benchmark. Take the ATA 64 memory benchmark with a little bit of a grain of salt, but at least it's consistent across our past runs and stuff we've done in the past. But also 82 nanoseconds of latency, which is really, really good for a registered error correcting platform. That's really kind of the Achilles heel, is that when you've got the extra registers are literally extra physical registers between the memory controller and the DIMM. It takes load off of the CPU, it adds stability, but it's another layer of things to redrive the signal, so you get another layer of latency. But out of the box, registered error correcting memory, especially on server platforms, is on the order of 100 nanoseconds these days. So shaving 20% off of that on this workstation platform is no small feat. With our max clock speed at 4.8 gigahertz on just a few cores, we're getting 1937. You can score over 2000 if you're willing to push it just a little bit. Geekbench doesn't actually soak this cooler, but these settings are relatively conservative for the settings that don't result in thermal throttling when I'm running our extended Cinebench R23 benchmark, if that makes sense. So if you build this exact configuration, you can expect even better scores than this in something like Geekbench, as long as you're not concerned with 24/7 rendering stability. And this is kind of the paradox of Sapphire Rapids. We saw exactly the same pattern on our really awesome Falcon Northwest system. I mean, look, Falcon Northwest has been in business since the beginning of time. Your company that you work for is not going to have any procurement problems buying from Falcon Northwest. They're like HP or Dell or other large names. They've been around since the beginning. They're just sort of the coveted Rolls-Royce brand as opposed to, you know, the commodity ham sandwich brand, if that makes sense. And they're confident enough in Sapphire Rapids to ship it in non-default configurations in terms of power usage. We're basically doing the same thing here. Yes, it would be nice if the power consumption, the power utilization were a little bit more reasonable, but even with a relatively beefy, admittedly, tower cooler that won't physically fit in our Lian Li case, you can manage the thermals on Sapphire Rapids and get some of the Sapphire Rapids exclusive features, like DDR5 and PCIe 5 and IAA for acceleration and some other performance things. It really is an interesting time to be alive. At the bone stock configuration, you really do give up a lot. You sort of start to see that in ATA 64 as well. It doesn't just make sense from the Geekbench point of view. You've got 30 gigabytes per second less memory bandwidth when we're running it, basically enforcing all the default limits because you lose your XMP profile. And again, XMP is basically free real estate. Why wouldn't you run that? It's 24/7 stable, basically, at least in a week or so of testing with this platform. So if we break down our baseline configuration really quickly with Geekbench, it looks pretty promising at first. Our single core score, it's really, really close to the single core score with the overclocks, but it's not really like that in reality. If we look at CPU-Z, there's almost 100 points difference between our 700 score that we were achieving previously and less than 600 that we're getting now for our single core performance. What gives? Well, it's not just the peak clock speed and the peak performance. For what Geekbench does, it does what it does so quickly and through so many different workloads that as long as the CPU is boosting relatively close to what it is for lightly threaded things, then there's not really a lot of difference between the overclocked profile and the regular profile. Of course, for gaming, the other thing that really matters for single thread, bursty workload type stuff, the gaming performance is considerably better on the overclock profile than it is on the baseline profile. So really, Geekbench is kind of a best case scenario for single core performance when you're running an overclocked versus a non-overclocked configuration, because it doesn't really show a lot of difference between the two. But real world, I would say, is more of a difference, more of a perceptible difference just using the system than what you see in Geekbench. Of course, the multi-core score really does tell the opposite story, which is, okay, running 24 cores with this much of an overclock, we're talking about more than a gigahertz difference. I mean, yeah, in the stock configuration, the CPU barely pulls more than 200 watts over a 15-minute extended period, but the performance difference is 20%. 20% from our 24/7 stable overclock, more power, 500-ish watts through the CPU versus the 200, 250 watt profile that the CPU defaults to. Yeah, that kind of makes sense. Now don't just quickly jump on the power difference there and say that it's all down to clock speed. It's also our XMP memory profile. The memory controller is going to use significantly more power to maintain that DDR5 6400 megatransfer setting, and the baseline configuration for memory speed with this kit of memory is DDR5 4400. Now it might be a little bit better with 4800, which I think is also an officially supported DDR5 memory speed, but it's probably going to be closer to 4400, especially if you're running 128, 256, 512 gigabytes of memory. The higher the capacity, the more difficult it is to achieve those blistering speeds. All of that's really just a lot of words to say that without really letting this CPU breathe proper, big cooling, beefy motherboard, and a nice airflow chassis, you're leaving 20% performance on the table. Easy. And you could probably get even more out of it if you're willing to put in more power and cooling and still have basically 24/7 stability. It's pretty nuts. Having used the W3175X system in the XL version of this case for so long and experienced some issues long term from that 24/7 overclock, namely curling at the edges of the processor. When that processor runs hot for a long period of time, the corners of the processor want to lift. I experienced that issue when it was still under warranty because, you know, I bought the CPU, which is just a whole other level of madness. I have a sickness, probably. It's fine. But it was fixed under warranty, so I can't complain about that. And the fix, the person that I talked to about it, I talked to another person and said, hey, this interesting thing happened. And they're like, yeah, we know, the edges can curl, we know. I'm told that this processor, design, packaging, whatever, has something to deal with that, and it could be the insane torque mounting pressure of this processor, but curling at the edges is a real thing on the W3175X. So yeah, but the W3175X has been very stable with an extreme overclock for a long period of time, which gives me a little bit more confidence in the, you know, extreme overclock that this platform has had. At the same time, you know, I get it why Intel is like, well, we don't really want to have everybody doing that insane 24/7 overclock on this platform out of the gate. I mean, it's not a good look. I can agree with that to some extent, but for workstations, if you get this much more performance for only another 100, 200 watts, it's 24 P cores. There's no E cores. It's just all P cores. 16 P cores for less than $1,000. 24 P cores for a little less than $2,000. These are workstation prices. For a game development machine, this is a pretty good platform because you can have all kinds of ridiculous insanity running in the background while you're also gaming with a high-end gaming GPU. because you've got so many performance cores. There are no efficiency cores. There's no efficiency cores. That must mean there's no efficiency, right? Well, that's the joke. Another way you can look at Sapphire Rapids power utilization is, okay, this is my W3175X system. I've got two 360mm radiators and a 1600 watt power supply, and the radiators struggle to keep it cool for the overclock that I'm running. And it's been 24/7 stable for 4 years. This actually uses less power and is more gen-on-gen gains than this. So a couple more generations of this and it's not going to be like that anymore. It's actually going to be much lower power and much higher performance. But like I say, I'll take the performance at pretty much any power cost. Famous last words. And that's definitely not a trade that I would make for servers, but for workstations. Unless we're being packed in like sardines in our working cubicles, that's probably fine. So with Geekbench, an ACE 64, and the dual power supply-ness of our Lian Li Dynamic X11, that's a pretty good introduction to the W790 platform on the ACE, the 4 memory channel version. If you're interested in the 8 channel version of this, be sure to check out our video that we did with our Falcon Northwest system, which has 8 DDR5 memory channels, and really, I mean, it's physically smaller than this, and has better cooling than this, and is a work of engineering art. They really did a good job putting that system together. You should definitely check that out, because that's a workstation. And this is the Intel W790 platform. That's been intimated to me, but not confirmed, so don't quote me on that. But there should be another generation of CPUs for this socket later next year sometime. So there is an upgrade path, although most people are not going to do that with their workstation. They're just going to get a new workstation and sell their old workstation, which makes sense in a lot of scenarios. But I am impressed with how fast the single thread performance is here, because the single thread performance of desktop class, i7 processors far outclassed what you could get from Xeon. At least on this platform, it's much, much closer. Okay, the 13900K can do about 710 to 720 out of the box with CPU-Z, for example, on the single thread score, well over 2,000 points in Geekbench, versus the almost, but not quite 2,000 here, but that is an out-of-the-box configuration. With my overclock, it was still close to about 2,000 points in Geekbench. I could juice it a little more, but again, 24/7 stability and being cooled by a tower cooler. So, could go either way. It is a lot of fun to do these kinds of things, though. I'm Wendell, this is Level 1. This has been a quick look at the W790-ACE platform, the 4 memory channel, sort of the what could have been high-end desktop. I really think this could have been HEDT, and there's kind of a clue in that some of the drivers from ASUS's website literally have HEDT in the file name. High-end desktop? Yeah, well, maybe. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.